Hello everyone, myself Dr. Naresh Kumar, Associate Professor, Department of Mathematics, Institute of Aeronautical Engineering, Dundigal, Hyderabad. Today in this lecture, I am going to discuss a basic concept of green theorem. How we can apply green theorem in our problem in the plane. So basically in green theorem we discuss about a relation between line integral which is equal to area integral. So I want to tell you how we can a line integral, how we can see the line integral equal to area integral, how it is possible. One side is line integral, other side is area integral, but how it is possible that line integral is equal to area integral? So this concept is given by the Green theorem. Green is the name of mathematician who give the concept of line integral equal to area integral, and this formula is very useful to solve the problem. So basic concept of green theorem in the plane is given. In this problem 100% plane is given, and relation between line and surface integral. So first point is definition of concept of green theorem in the plane. What is green theorem in the plane? Definition of green theorem in the plane. I want to discuss and define what is green theorem in the plane. So if S is an open surface, any surface S is any surface which is open bounded by a closed curve C, and F equal to Mi plus Nj. This is two-dimensional vector point function F. F is vector point function that is represented by force. Vector point function. This is the force in vector form. Any vector point function in two dimension having continuous first order partial derivative, then this is the condition must. If S is any open surface which is bounded by closed curve C and a vector point function F that is represented by force, F equal to Mi, I is cap, and plus Nj, J is cap, Mi plus Nj. This is two-dimensional vector point function that is represented by a force, is any vector point function having continuous first order partial derivative. Then we have the F is two-dimensional vector point function in any xy plane. F is vector point function, two-dimensional vector point function in any xy plane. So I want to discuss here, this is z-axis, this is x-axis, and this is y-axis. Okay, this is I cap, k cap, this is j cap, and this is I cap. Clear? So this is the xy plane. This is known as a xy plane. Now this plane is given, and this is a surface. Plane is always be a surface of any body. So now what is perpendicular to this? So I am discussing here a result which is perpendicular to this. This is this perpendicular, this type. This is perpendicular to Z. So a vector which is perpendicular to the Z, to xy plane, that is known as a unit normal vector. This is n cap. Unit normal vector is n cap, and this is k cap. So n cap equal to k cap. In this result, we can find n cap equal to k cap because n is a unit normal vector which is perpendicular to xy plane. What z axis is the perpendicular to xy plane, and unit normal is also perpendicular to the xy plane. So n vector and k vector both are parallel. Here n vector and k vector both are parallel. Okay, so this is parallel. So we can say that n vector equal to k vector. This is the main property in this theorem. In Stokes theorem, n vector is not parallel to k vector. The direction of n is different. So the n unit vector is equal to cos alpha I plus cos beta j plus cos gamma k in Stokes theorem. We have considered the value of n vector is equal to cos alpha I plus cos beta j plus cos gamma k in Stokes theorem. But in Green theorem, the main concept is n unit normal vector is parallel to k vector. Means the direction of unit normal vector along the z axis. So we can say that n unit vector is equal to k vector. So n equal to k, we can write. So now here, this is any line integral, single integral under curve C, any closed curve, and curve. If we integrate along any curve, that is known as a line integral. So this is curve C, integral under curve C. This is f vector point function 2-dimensional, and this is dr vector. Dr vector, this is the differentiation of position vector at any point P. This is the differential. Dr vector is the differentiation of any position vector at point P. F is the 2-dimensional vector point function. So this equal to double integration under surface curl f dot n ds. This is the formula for Green theorem. So now in Stokes theorem, we have already discussed about Stokes theorem, but there is some difference between Stokes and Green. When we are studying of Green theorem, then parallel we study of Stokes theorem. Okay, so Stokes theorem, f is 3-dimensional vector point function. F is 3-dimensional vector point function. F vector is, this is f1 I plus f2 j plus f3 k in Stokes theorem. And here n cap, this equal to cos alpha I plus cos beta j and plus cos gamma k. This is the n vector in Stokes theorem. But in Green theorem, f vector is 2-dimensional vector point function. So f is here, f vector is value of f vector, this equal to m I cap plus n j cap. N vector is equal to k vector. These 2 points are different. This is the Green theorem and this is the Stokes theorem. Stokes theorem is 3-dimensional and Green theorem is 2-dimensional. So now integration, above formula is given in vector form and is unit normal vector perpendicular to given the surface, basically xy plane. Now change the above formula in vector to scalar form. How we can change the Green theorem formula which is given in vector form, convert in scalar form. So this is formula 1. This is known as a scale vector form formula. So this is integral under curve C, f vector dot dr vector equal to double integration as curl f dot n ds. But this formula is 2-dimensional formula under the surface S. So now convert equation 1 in vector form to scalar form. How we can convert to vector to scalar? So here f is any vector point function. This is given m. m into I cap plus n into j cap. There is only two dimensional. I and j vector are there. There is no k vector. This equation 2. And 3 is n cap equal to k cap. This is most important point. Equation 3 is most important point. N vector unit normal vector is equal to k unit normal vector. Both are same because the direction of unit normal vector along the z-axis. But along the z-axis, k vector lie. K vector is working along the z-axis and the unit normal vector n in the direction of k. So both are parallel. It means n vector equal to k vector. This is the main concept of Green theorem. There are 2 points are main in Green theorem. First is vector point function is two-dimensional vector. And unit normal vector n equal to unit normal vector k. This result is given in Stokes theorem. So now, first of all, here R vector is position vector. R vector is number 1 point is most important point of Green theorem. Most important points of Green theorem. Number 1, F vector. This is two-dimensional vector. Mi plus nj. Okay. Second result is n vector equal to k vector because n vector parallel to k vector. N unit normal vector parallel to k vector, so we can say n vector equal to k vector. N vector equal to k vector. Okay. And f is two-dimensional vector point function in the given surface, that is mi plus nj. These 2 points are very important points in Green theorem. So now R vector is the position vector of a point P on the surface. So that is represented by xi plus yj plus zk. This is equation 4. Now differentiation of R vector, we get dr vector. Dr vector is dxi plus dyj plus dzk. 1 dx is dxi plus dyj plus dzk. So now finding curl f. What is curl f? Curl f represented by del cross f vector. Del cross f. So del cross f determine with the help of determinant. Determinant, first of all, writing I cap, j cap and k cap in first row. In second row, we know del. Del is I dou over dou x plus j dou over dou y plus k dou over dou z. This is the value of del. So now coefficient of I is dou over dou x. Coefficient of j is dou over dou y. Coefficient of k is dou over dou z. So putting here second row, dou over dou x, dou over dou y, dou over dou z. And next in F vector. In F vector, two-dimensional vector. So coefficient of I is n, coefficient of j is n, and coefficient of k is 0. So when we find the curl f, then that is known as a del cross f. Del is a vector and f is a vector. Both are vector. Both are three-dimensional vector I, j, k. So now first row we write I, j, k. I, j, k are unit vectors. And in second row, taking the coefficient of I, j, k in del. In first vector del. So in first vector del, the coefficient of I is dou over dou x, coefficient of j is dou over dou y, coefficient of k is dou over dou z. So second row, we are taking the coefficient of I, j, k in first vector respectively. Now third row, we are taking the coefficient of I, j, k in second vector F vector. So in second vector F vector, the coefficient of I is m, coefficient of j is n, and coefficient of k is 0. After solving this determinant, we get this curl F vector. So now first of all, I am taking I cap, this is I cap, and eliminating first row and first column. Then multiply by this to this. So dou over dou y of 0 minus dou over dou z of n. Next second, taking j. J is negative sign, minus j. And first row and second column cutting. So multiply this to this and minus this to this. Dou over dou x of 0 minus dou over dou z of m. And last, be taking here k. This is third one is k. And k first row cancel and third column cancel. Now multiply by this and to this. So dou over dou x of n minus dou over dou y of m. So now next curl f equal to here. First this result is 0. Dou over dou y of 0 is 0. So now minus dou n over dou z I and dou over dou x of 0, this is 0. So minus minus plus dou m over dou f, this is plus dou m over of dou z, j, and plus k is this. Also C is closed curve in xy plane. Then we write n vector equal to k vector. N vector perpendicular to xy plane. So the direction of n vector along the k vector. So n vector and k vector both are parallel. So n vector equal to k vector. We can write this. So now we will find here curl f dot n. Curl f dot n. So what is curl f? Curl f minus dou n over dou z I plus dou m over dou z j plus k. Dou n over dou x minus dou n over dou y dot n. Putting n equal to k. Taking here. So now curl f dot n minus dou n over dou z I and minus dou m over dou z j and plus, this is plus sign, and dou z k, dou n over dou x minus dou this k. So this is k vector. Here I0 and J0. So multiply to k dot k. K vector dot I vector. This is 0. K vector dot J vector. This is 0. Only write k vector dot k vector. This is 1. So here multiply this one, this. So we write this. Curl f dot n equal to dou n over dou x minus dou m over dou y. This is equation 7. We find f dot dr, f vector and dr vector. F vector is mi plus nj. Two-dimensional vector is vector f. F is vector point function. And dr vector is the differentiation of position vector r. So we write here dxi cap plus dyj cap plus dzk cap. Now taking dot product on both sides. So taking dot between I to I, j to j and k to k. But in first vector there is no k. So here we write f dot dr equal to m dx plus n dy. These value putting in equation 1. So this is formula is in vector form. Now integral C here m dx and dy equal to surface curl f dot n or k. F curl f dot k. This ds. Okay. So this is the main formula. Putting this value this. So now m dx plus n dy curl f dot k ds. Final is this. This formula is known as a green formula. This is known as a green theorem. This is representing the line integral equal to area integral. This is line integral and this is area integral. Okay. This is the main formula of green theorem. So finally we see that in green theorem In green theorem, only 2 points remember. Number 1, f is f vector. This is two-dimensional vector point function, that is mi and plus nj. Two-dimensional only. Third is no. And next is n unit normal vector. This is k. Here n vector parallel to k vector. Okay. These 2 points are very important for green theorem, and we are taking three-dimensional. N is also three-dimensional vector and f is also three-dimensional vector. Then this formula convert into Stokes theorem. Okay. This is the main difference between green theorem and Stokes theorem. Stokes theorem is three-dimensional vector point function. All vectors is three-dimensional, and in green theorem vector is two-dimensional and n vector parallel to k vector. Now we want to solve one problem based on green theorem. How we can use the green theorem in our problem? So I want to discuss here in detail. Why they use Green's theorem? So that area bounded by a simple closed curve C is given by this. Why the use of Green theorem? So that the area bounded by closed curve is given by this. Hence find the area of an ellipse. Area of an ellipse. So solution, why Green's theorem in the plane? We have the formula. We have the following formula. Okay. Why Green's theorem in the planes? To solve this problem, we use a Green theorem. With the help of Green theorem, we solve this problem. So solution by Green's theorem in the plane, we have this following formula. This is represented by equation 1. This is line integral, and this is right hand side is area integral. So the formula, this is known as a Cartesian form. This equation is known as a Cartesian form. So left hand side integration c. This is integral under any curve. M dx plus n dy. Two-dimensional curve. And this double integration r. R is any region. Dou n over dou x minus dou m over dou y. Dx dy. But now we have given this integral. We want to find the value of this integral. So this integral is line integral because this is single integral. We have given integral, that is line integral. What in our formula is line integral? This. So comparing this, here this is line integral and this is formula. This is given in our question. This is given in our formula. Both are putting same, equal. Then after comparing, we get this here. What is m? What is value of m? Okay, we are not taking half, only this result. Half is not taking there. So here x dy minus y dx. After comparing here, m is the coefficient of dx. So coefficient of dx is this. So m is minus y. Coefficient of dy. Coefficient of dy is this. Coefficient of dy is x. So here m is minus y and n is x. So now differentiating m with respect to y. Dou m over dou y. This is minus 1. Differentiating n with respect to x. Dou n over dou x equal to 1. Hence 1 we have. Why the formula 1 we have? Integration c minus y dx plus x dy equal to double integration r. Dou n over dou x. Putting this value in formula. Putting value from 3 in formula 1. Formula 1. Formula 1 is this. Equation 2. Then we have this. Y dx plus x dy equal to double integration dou x over dou x minus dou over dou y of minus y dx dy 4. So double integration are this one plus this one dx dy. So this 2 dx dy. This is 2a. Here let a equal to double integration r and dx dy. So this is 2a. Now a is the required area of an ellipse. Any point on xy on the ellipse is given y. X equal to a cos phi and y equal to b sin phi, where phi is parameter. This is parametric form of an ellipse, because ellipse equation of ellipse x square upon a square plus y square upon b square equal to 1. We consider here x equal to a cos phi and y equal to b sin phi. These equation vary phi to 1. So here a square cos square phi upon a square plus b square sin square phi upon b square. This cancel. So this is 1. So these are the parametric form of an ellipse. We can put in any ellipse this point. So now here taking 1 upon 2. This is 1 upon 2 now. Writing 1 upon 2 minus y in bracket. Minus y is this. Y is b sin phi and dy. V sin phi, y is minus y. Minus y is b sin phi. Differentiation of dx. Here putting this value. Minus b sin phi and d of x. X is a cos phi. And plus x is a cos phi dy. Dy means differential of y. Y is b sin phi. So now a cos phi differential of b sin phi. B sin phi means b cos phi d phi. Minus b sin phi differential of cos phi means minus a sin phi d phi. So minus minus plus. So this is 1 upon 2. Now this equal to 1 upon 2. AB is common. Cos square phi plus sin square phi d phi. And here sin square phi plus cos square phi is 1. So here 1 upon 2 AB 0 to 2 pi d phi. In ellipse, the phi goes from 0 to 360 degree. In any ellipse is this, and this is origin, this x-axis, this y-axis, this is origin, and this is any point P, Pxy. This is very phi to equation of ellipse. This is OP. This is angle phi. So phi here, phi is minimum 0 and phi maximum is 2 pi. So one circle complete. This complete one cycle, okay? So this angle, this anti-clock direction. So theta phi equal to minimum 0 and phi equal to maximum 2 pi. This is the limit of phi covered to this region, area of an ellipse. So this equal to 1 upon 2 AB phi, putting the value of phi, here limit 2 pi minus 0. So this is 1 upon 2 into 2 pi. So this equal to 1 upon 2 AB and into 2 pi. 2 is cancelled to this, so pi AB. Pi AB is the area of an ellipse. Okay. Now problem 2 based on Green theorem. This is also very important problem. With the help of here verify Green's theorem. First of all, we want to verify the Green theorem. With the help of this curve, this function, this curve, this is verify the Green theorem or not. So here be solution. This is very important question. Solution. Verify the Green's theorem this, where C is the boundary of the square whose vertices are this and this. First of all, making any diagram. So diagram is this. This is x-axis and this is y-axis. Okay. This is z-axis. Now, this is origin. Value of origin is 0, 0. And this is point A. A point. This is 2, 0. Coordinate is 2, 0. Now next point is this. This is point B. Point B is 2, 2. And this point, this is C point, this is 0, 2. Okay. So our region bounded by this is the region. We find out the value of this region. This is the region. So with the help of line integral, first of all this OA, integral with OA, we find out. Second this one OB, third one this one BC, and third is CO. So according to line integral, we find the integral of this. So here integral C x square minus xy cube, integral C xy minus x cube, and here d dx xy cube. And dx plus x square minus xy cube, x square minus xy cube dx, and plus y square minus 2y, plus y square minus 2y, and into dy. This is the line integral. This equal to must be double integration region R dou n over dou x minus dou m over dou y and dx over dy. Clear? So first of all, we find out the value of left hand side. So first, number 1, finding value of LHS. LHS, this integral C, here x square minus xy cube and dx plus y square minus 2y and dy. Okay. So this is the line integral. So basically square is given. So square, there are 4 lines. First O to A, next A to B, B to C, and C to O. So we finding out the integral along 4 lines. So this is integral equal to I1 plus I2 plus I3 and plus I4. Okay. I1 is the integral along line OA in the given diagram. So what is along OA? We see that along OA, along OA, number 1, this is y equal to 0. Along OA, y always be 0. Y always be 0. Y0 means dy 0. What is x? X goes to 0 to x equal to 2. This is the limit of x. This is y0 and dy 0. So now integral C means OA. Integral along OA. This is I1 integral. OA here putting y0. In this integral putting y0. What is y0? Means y0 and dy 0. So here x square dx. First is x square and dx and plus y0. First of all I am writing integral here. Integral here C is here x square minus xy cube dx and plus y square minus 2y and dy. This is line integral which is given in our question. So now along OA, this I am finding along C is OA, along OA, O to A. So here y is 0. I1 is the integral along line OA is given diagram. Diagram is y is 0. So dy 0. Limit of x. Limit of x is 0 to x is 2. X is 0 to x is 2. So here OA, putting y equal to 0 and dy 0. So here x square dx and plus this 0. This is I1. So I1 equal to OA means x equal to 0 to x equal to 2. X square dx. And integrating this x cube by 3. So now limit 0 to 2. So this equal to 2 ka cube by 3 minus 0. So this is 8 by 3. This is I1. Okay. This is the value of I1. First of all, in left hand side, we find the integral of line integral along only line OA. Now next, I2. I2 is the integral along line AB. Along AB is, what is along AB? Along AB. AB is x equal to 2. X equal to 2. And y goes to 0 to 2. Here along AB x equal to 2. And dx is 0. Integral along y axis. So limit of y equal to 0 to y equal to 2. So we get here integral c x square minus xy cube dx and plus y square minus 2y and dy. This is integral given in our question. This is I2. So I2 is equal to integration c means AB. Integral along AB. So x square. X 0 means dx 0. X 0 means dx 0. Limit y 0 to 2. So x dx 0. Dx 0 first integral is vanished. And value of y square minus 2y and dy. Putting limit y is 0 to 2. Y square minus 2y and dy. This is odd integral. So here integration this y cube by 3 minus 2y square by 2. Putting limit 0 to 2. This 2 is cancelled. So 2 ka cube means 2 ka cube by 3 and minus 2 ka square y square minus 0. So 8 by 3 minus 4. 8 by 3 minus 4. So this equal to 8 minus 12 by 3. So this equal to minus 4 by 3. Okay. This is the value of I2. Next one I3. I3 is the integral along line BC. What is BC? BC is this line. Here y 0, here y 2, here y 0 and here y 2. Along line BC, y equal to 2 means dy is 0 and x belong 2 to 0. Limit of x is and limit of x is x equal to 0 to x equal to 2. First of all, y equal to 2, dy is 0 and x limit from 0 to 2 when we integrating along BC. So I3 equal to integration c x square minus xy cube dx and plus y square minus 2y dy. Now integration along BC I3. I3 is the integral along BC. So here dy is 0, means this result is 0. And y is equal to putting 2. So y equal to x square minus x and 2 ka cube and dx. So this equal to here BC limit of y is x 0 to 2. Now x square minus 8x and dx. So this is x cube by 3 minus 8x square by 2. Putting limit 0 to 2. So this equal to here 2 ka cube by 3 minus 8 and into 2 ka square by 2 minus 0. So here I2 is equal to I3. I3 is equal to here 8 by 3 minus this 2 is cancelled. 8 by 3 minus 16. 8 by 3 minus 16. Okay. So this equal to 8 minus 48 by 3. So this equal to minus 40 by 3. This is value of I3. At last, integral along line CO in diagram, in given diagram. In given diagram. So in CO, we see that CO is this. So CO is x equal to 0. X equal to 0 and y varies 2 to 0. In M, x equal to 0 and dx is 0. Limit of y is y equal to 2 to y equal to 0. Putting these limits in integral, then we get I4. I4 integral C y x square minus xy cube and dx plus y square minus 2y and dy. So here x is 0 and dx is 0. Now limit of y is 2 to 0. So putting here integration CO along integration, this is I4 last, this is CO. So here putting dx 0, this term is 0 and y equal to y square minus 2y dy. So now two to zero here, y square minus 2y, y square minus 2y and dy. Now integral of this. So here integration is y cube by 3 minus 2y square by 2 and putting limit. So now here 0 and 0 minus sign, and first of all putting 2 ka cube by 2, 3 minus 2 ka cube, 2 ka cube by 3 minus 2 is cancelled and 2 ka square. So this equal to minus 8 by 3 and minus 4. This equal to minus 8 by 8 minus 12 by 3. So this is minus, here is minus 4 by 3. So this equal to 4 by 3. This is I4. Okay. So this is I4. Value of I4. I3 is, what is I3? Minus 40 by 3. So we get here integration c x square minus xy cube dx and y square minus 2y and dy. So this is line integral. This equal to I1 plus I2 plus I3 plus I4 along OA line plus AB line plus BC line and plus CO line. This is square. So what is value of I1? We have calculate value of I1 is I1 8 by 3, I2 is minus 4 by 3, 8 by 3 minus 4 by 3, 8 by 3 minus 4 by 3. And what is I4? I4 is 4 by 3 plus I3. I3 is minus 40 by 3 minus 40 by 3. So this term is cancelled to this 8 by 3 minus 40 by 3. So this equal to 3 is LCM and here is 8 minus 40. So this is minus 32. 32 by 3. This is the value of the integral. This is the value of left hand side. Now we find out the value of right hand side. RHS. Value of Green theorem of RHS. Right hand side. So that is formula is double integration region R and here is dou n over dou x and minus dou m over dou y and into dx dy. Clear? But here what is m? M is given x square minus xy cube and n is given what is n is y square minus 2y. So find it here dou m over dou y. This equal to differential with respect to y here. So that is 0 minus x into 3y square. Differential with respect to n. Dou n over dou x. So x is differential with respect to x is 0. There is no x function. These value putting here integral double integration R is region, dou n over dou x is 0 minus dou n over dou y 3xy square and dx and dy. This is right hand side of the Green theorem. Left hand side we have find out the value. So double integration here region R, here is 3xy square and dx and dy. But now limit of y here. Double integration R xy square 3xy square dx and dy. So integration of here x equal to 0 to x equal to 2 and here y equal to 0 to y equal to 2. This is the limit. So finding value of 3 is common. 3 is common and here x y square dx and dy. Integrating first y with respect to y. So here 3 x equal to 0 to x equal to 2 and x dx now integrating of y square dy, integrating y equal to 0 to 2. So now this result is 3 integration x equal to 0 to x equal to 2 x dx. Here is y cube by 3. Now limit 0 to 2. Okay. So this is 8 by 3. This equal to 3 integration 0 to 2 x dx and here 2 ka cube by 3 minus 0. So now this equal to here 3 integration 0 to 2 x dx, and here is 8 by 3. So 3 is cancelled. Now 8 is common, and here x square integration to 0 to 2 x dx. So integration 8 integration of this x square by 2. So 0 to 2. So 8 here 2 का square by 2. So 2 is cancelled. So here is 16. 16 is this result. Right hand side have 16 value, and left hand side is I1 plus I2 is 16. Here is not 3. This cancel this. So this is also 16. I1 plus I2 plus I3. This total is 16. So LHS equal to RHS. So this is verify Green's theorem. Okay. Hence verify Green's theorem. What is question is saying here? X square xy cube y square minus 2y dy. So here where verify Green's theorem this, where C is the boundary of the square whose vertices are this. Okay. So this type of, first of all we find the value of left hand side integral, that is line integral. What here is square is given according to vertices 0, 0, 2, 0, 2, 2 and 0, 2. These are 4 vertices. 4 vertices, length and breadth are same. So this is a square is given. This is square. Matlab curve is square. So we find out the integral of left hand side in 4 lines. 4 lines means starting from O to A, next A to B, and B to C, and C to O. So after finding 4 integrals, and we are adding I1 plus I2 plus I3 plus I4. First of all we find integral along OA. Along OA y always be 0. Y0 means dy 0. What integral along OA means along x-axis. So x-axis along, vary the value in x. So x from 0 to 2. Next is along AB. Along AB is a line which is x equal to 2. X equal to 2 means dx equal to 0. But here is y vary. X is not vary. X is constant. Y is varying along AB. So y vary from 0 to 2. So after finding second integral along AB, third integral along BC. Along BC y is 2. Y is 2. This is third integral. I1, I2, I3. Third integral. What is third integral? Y is 2. So here 2 ka cube. Here is 8x. So x cube by 3 means 2 cube by 3 minus 8x. 8x x square by 2. So 2 is cancelled. 8 2 is 16. So here is minus 40 by 3. I4. This is total this. Now integral of this. Dou m over dou a by this equal to y. Let be differential with respect to y means 3y square. 3xy square. And differentiation of n with respect to x means 0. So minus 3xy square. 3xy square dx dy. So here 3 is common, xy square. So here xy square limit is 0 to and 0 to 2. X is common, y square by 2. Y cube by 3 here. So this is 8 by 3 and x square by 2. This is 4 by 2. 3 is cancelled. So this is 16. Okay. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.